practice circuits problem, I just made this one up. So here we have 3 resistors and 2 batteries. And the question is, what's the power dissipated in this 10 ohm resistor? So 3 volt battery, 20 ohm, 30 ohm. Notice the orientation of the batteries. Let's just get to it. So if I want to calculate the power through this, I can calculate power as I times V. But I can say V is I times R for that resistor. So this would be I squared R. So I need to know the current in that resistor in order to calculate the power. Well, I don't know any of the currents, so I'm going to have to find all the currents. So let's just find the 3 currents in this circuit. So I'm going to start off by labeling them. I'm going to call this I1, and that current's going to come up here, and then someone's going to go this way, I2, and someone's going to go that way, I3. Now, the direction on that may indeed be in the wrong direction. That's fine. First of all, it's fine because we're just calculating the power. Second, if we get the wrong direction, it will get a negative value. So I have these 3 variables I don't know. How do you solve 3 variables, 3 unknowns? Well, I'm going to need 3 equations. So the first equation I can use is the junction rule. So the junction rule says that if I have a junction, say right here, the total current coming into the junction is equal to the current coming out of the junction. So here I have current I1 coming in, so I have I1, and the current coming out is I2 and I3, I2 plus I3. So that's one equation with 3 variables, so I need 2 more equations. I can get 2 equations from the loop rule. I can't do another junction, right? Because here's the only other junction over here. But if I did that, I would get I2 plus I3 equals I1, which is the same as that. So it doesn't help me. Okay, so there are actually 3 loops, but I only need 2 of them. The 3 loops are this loop, and this loop. I'm just going to pick 2 of them. I'm going to start here and go all the way around the loop. And remember, the loop rule says that the change in potential around a loop is equal to 0. So let's add up, start here, go around the loop, and add up the voltages. Remember that if I go from the negative to the positive side of the battery, that's a positive change in potential. If I go across a resistor in the same direction as the current, that's a negative change in potential, negative IR. Okay, so I'm going to start here. I'm going to go up here. I'm on this wire, and we're assuming perfect wire, so there's no change in potential on that. Now I'm going this way. Notice that I'm going this direction, but the current is that way. So I'm going to get a positive potential change across this. It's going to be plus 30 I3. Now I go from the negative to the positive side of the battery, so that's going to be a positive change in potential, plus 5. I'm leaving off the units. And then I'm coming down here. Now I'm going across this resistor. I'm going in the opposite direction again as the current, so I'm going to get a positive change in potential. It's going to be plus 10 I1 because the current's I1. And then finally I'm going from the positive side to the negative side of this 3 volt battery. So that's going to be negative 3 volts, and that's equal to 0. Let's just combine the 2 voltages together. I have 5 and negative 3 is going to be, you can get your calculator, but it's 2. So I have 30 I3 plus 2 plus 10 I1 equals 0. And right away you can see that I made a bad choice. It's not possible for I3 and I1 to both be positive if all these numbers have to add up to 0. But it's fine. It's totally fine. Okay. But here I have 1 equation, 2 equations. I'm going to put this equation up here. 30 I3 plus 2 plus 10 I1 equals 0. Now we can erase this and put our next equation. So let's do another loop. We can pick whatever loop we want. Well, we can't pick the same loop. I'm looking right here. They're both going to be the same thing, two resistors. I'm just going to do this loop right here. So starting right here, I'm going to go up, and now I'm going to go across this 20 ohm resistor. I'm going in the opposite direction as the current, so it's going to be plus 20 I2. Now I'm going to come down here. I'm going to go in the opposite direction as I1. It's going to be equal to plus 10 I1. And then finally, I'm going across the battery. So I'm going positive to negative. So this is going to be minus 3. Put a box around that. Put a box around that. So I have 3 equations, I have 3 unknowns, and I want to solve for those values. I really want I1, but I'm going to kind of have to solve for everything. So let's just not worry about that right now. How do you solve 3 equations, 3 unknowns? There's many different ways to do this. I mean, you could make a matrix, you could take the inverse of a matrix, you could set up a system of linear equations, but I'm just going to use the tried and true method of solving for a variable and plugging into the other equations. That's what I'm going to do. Okay, so here I have I1 equals. So I'm going to put in over here I1 as that, I2 plus I3, and I'm going to put in I1 here as I2 plus I3. So I'm going to get 2 equations, 2 unknowns. So let me rewrite that equation. It's going to be 30 I3 plus 2, and then plus 10 times I2 plus I3. So it's going to be plus 10 I2 plus 10 I3. I multiplied it out, equals 0. Now let's just simplify, because I have the 30 I3 and a 10 I3. I can combine those two together. I get 40 I3 plus, I'm going to switch the order, plus 10 I2 plus 2 equals 0. Now I'm going to take that same I1 equation and plug it in here. So if I do that, I get 20 I2 plus 10 I1, which is going to be 10 I2 plus 10 I3 minus 3. And here I'm going to combine these two, so I get 30 I2 plus 10 I3 minus 3 equals 0. So there, now I have 2 equations and 2 unknowns. Now I'm going to do the same thing. I need to solve one of these for a variable and substitute it into the other one. So let's run out of room. So I'm going to erase this. Oh, that was a bad idea. Let's keep that. I1, 10. Okay, let's just erase this. So I'm going to put those 2 equations over here. 40. I'm going to write smaller because that's my problem. I'm not efficient with my space. And then 30 I2 plus 10 I3 minus 3 equals 0. Okay, so now I can delete these. I'm going to delete. I always say that. I'm going to erase these. I want to keep my original equations right there for right now. Okay, so let's take one of these and solve. I'm going to take this one and solve for I2. I don't even know why. So I'm going to subtract 2 and subtract that from both sides. I get 10 I2 equals negative 40 I3 minus 2. Now I'm going to divide both sides by 10. I get I2 equals negative 4 I3 minus 0.2. If I divide that by 10, I get 40. 40 divided by 10 is 4. 2 divided by 10 is 0.2. Now I can take that and put it into this equation right here for I2. So I get 30 times I2 is going to be, I'm going to write this out, 30 negative 4 I3 minus 0.2. That's that right there. And then I have a plus 10 I3, and then I have minus 3 equals 0. But here we have it. We have one equation, one unknown. So we can go to town on this thing. I'm going to move the 3 to the other side, add 3 to both sides. And then I'm going to multiply this out. So I get negative 120 I3. 30 times negative 0.2 is going to be negative 6. Negative 6, right? Yeah. Negative 6 plus 10 I3 equals 3. Now I'm going to add 6 to both sides. Now I have negative 120 I3 and 10 I3. So this is negative 110 I3 equals 9. You notice I haven't even had to use the calculator yet. I3 is going to be 9, negative 9 over 110. Now I'm going to use the calculator. Okay, 9, 110 divided by. And I get I3, I'm going to put it up here. I3 is 0.082. Now that I know I3, I can put it into this equation, and I get I2. So this is going to be equal to -4 times, that's negative. So I got I3 backwards. -4 times -0.082 minus 0.2, and I get, so that's going to be positive 4 times 0.2 minus, and I get 0.127. So I2, 0.127, and then I1 is going to be I2 plus I3, so it's 0.127 minus 0.082 0.045. 0.045 amp. Okay. Oh, look at that. You can't even see it. Okay, sorry. Now I can find the power. P10, the 10 ohm resistor, is going to be I1 squared times R. So that would be 0.045 squared times 10. I'm not going to do that in my head. I'm going to use my calculator. 0.045 squared time, enter, 10 times. I get 0.02 watts. The end. Yeah, I was waiting for that thumbs up. Okay, so just remember, I kept those equations up there because once you get those equations, I mean, it's no longer a physics problem, it's a math problem. Now I'm just solving 3 equations, 3 unknowns. There's no physics. The physics is getting those equations. And it's important to kind of remember that as you're working through problems like this. Okay.